There, I'm Clifford Bates, and welcome to Basic Political Science Methods. Today, we're finishing up Chapter 2 with the discussion of Van Evera's guide methods of political science, students for political science methods. The case Chapter 2's case studies we're wrapping up with the case selection criteria for case studies. Okay, and this is a big discussion, so we're going to be, going through it. So let's go to it. Okay, just go shrink up over here. We're going to be going back and forth, but just like that. So, okay, now we got a little room. We can make this a little bit bigger so we can see me. So, voila. Case studies criteria. Case studies criteria starts off and Evera says, predictions of case studies have produced neither. Prediction of case studies have produced neither a comprehensive catalog of possible case study research method designs, nor have comprehensive list of case study selection methods, nor a comparative list of these methods. Right. So therefore, this is like he says, 45. He says nothing. Noting this failure, as Lynn does this. Right. There's no complete list. Practitioner list. Accordingly, I have made my own list of useful case selection criteria. These criteria evolve from discussions with people. He says, my list of 11 criteria does not exhaust the logical possibilities, but it includes all that seems strong to me. Especially, I argue that the following cases attributes are possible reasons for case selection. In other words, he's going to go through it. These, I think it's, he says, 1, data richness; 2, extreme values on independent variables. Or dependent variables or conditional variables. So extreme values on either the independent variable, dependent variable, or conditional variables. The conditional variable is what? This is a variable that frames the antecedent condition, right? 3, large within case variance in values on the independent, dependent, or conditional variable. So, in other words, extreme values not large within case variance of values of things. 4, divergence of prediction made of the case of competing theories. So different theories make different things, so the divergence of predictions based on different theories. 5, the resemblance of case background conditions to the conditions of current policy problem. So, what are certain policy problems? What are the conditions of current policy problems? And the case's background conditions, do they meet that? The correct resemblance to this, right? The protypicality, proto means before, or typicality of case background conditions. So how typical are the case background conditions? 4, appropriateness for controlled comparisons with other cases, mainly using Mill's method of difference, right? How appropriate are they? You can, again, emphasizing difference rather than some agreement. How appropriate for appropriateness of controlled comparisons with other cases, right? 8, outlier characteristics, the outlier character of a thing. 6, intrinsic importance. Okay, now this is where I'm going to have to shrink a little bit. Okay, I'm at my edge, and therefore I can't go any further here. So, intrinsic importance. 10, appropriateness for replication of previous tests. So, therefore, how can you replicate previous tests? And 11, appropriateness for performing previous omitted style tests. So, replication and doing omitted tests, right? Those are the 11 criteria here. He says, now, he mentions these 11 types, but then he goes, this list generates 2 general criteria for case selection. So these are the true general criteria. First, so even though we have 11 types, we have 11 of these criteria. But of these 11, you have these list of 11 criteria produces 2 general criteria. First, investigators should select cases that best serve the purpose of their inquiry. So, pick cases that best serve the purpose of their inquiry. As noted earlier, there are five purposes for case studies: testing theories, creating theories, identifying possible antecedent conditions that test theories that antecedent condition that theories require to operate, testing the importance of an antecedent condition, explaining cases of intrinsic importance. Right? These five are the reasons why we do it. The selection criteria that is most appropriate differs from purpose to purpose. Hence, investigators should be cleared in their purposes before they select cases. This means you cannot know what cases are best to select until you frame your questions. So you have to have a good question first, and then you look for the case that fits your thing, right? Decisions on case selection are premature before you know what you want to know. You have to know what you want to know, then you select cases. So, what do you want to know? What do you want to know? You answer that question first, and then you decide what kind of case you want, right? Some of the following case selection criteria are appropriate for most purposes, but some only serve one or two purposes. So, of those 11, some of these are multiple purposes criteria appropriate for most purposes, but some of these only are for one or two, right? Hence, investigators should take care to match criteria to purpose, the type of criteria to the type of purpose. Now, this is what he's going to do now. Rest this, he's going to look at every single thing, and he has at the end of this thing, he has this wonderful. I hope it's a good scan. Mm. Yeah, it's a decent scan. This little thing on page 88. This is a wonderful scan of this. These are the criteria. This is the cross case collection criteria, the 11 of them. And here's are that. And this is when it's appropriate, right? When it's not appropriate, okay? So we'll just go back to where we were. Did I go too far? Hold on, let me see. Eight, seven. Hold on, I'm going to go too far. Didn't go. Sorry about that. So two, three, two. So so, so they're appropriate. We match these two things, right? Case selection criteria therefore investigate should therefore differ with the stage which the investigator stands. So therefore, where are you? The case collection criteria this should therefore differ with the stage which investigator stands. Investigators first seek to infer theories, then seek to test theories, then to test their range or their external validity by inferring and testing antecedent conditions. Rules for case selection varies across these tasks, hence varies with the stage of the inquiry. So therefore, what are you going to do? What cases you do depends on where are you. So not only what kind of questions you're going to ask, what stage of the inquiry are you at? Are you at the are you going to pick this to create theory? Are you going to then that says first infer theories, test theories, then test their range or validity by inferring and then testing antecedent conditions, right? Each one of these are different stages and different requirements. Now, the second general rule, second general criteria, when testing theories, investigators should select cases to maximize their strength and number of tests they let the investigator perform. So, therefore, you should maximize testing theories. When testing theories, investigators should select cases that to maximize the strength and number of tests they are going to let the investigator perform. The best case selection allows the most strong tests. The test of predictions, tests of predictions that are certain and or unique, with the least research effort. So in other words, again, this is the best case selection allows for the best, strongest test. That is that they with the least research effort. Some of what follow repeats remark made earlier about inferring and testing theories and async conditions, since methods of case selections are aspects of general method inquiry. So therefore, this is very much tied to what was repeated earlier. So first, data-rich cases. Select data-rich cases. We learn more from cases, data studies that let us answer more questions about the case. The more data we have, the more questions we can answer. Hence, more tests are possible. Hence, data-rich cases are preferred. Other things being equal, right? 49. Right? This is like the point. Other things being equal, this is the best case. The cases that are data rich are preferred to things that are less data. Selecting cases for data richness is especially appropriate if you plan to infer or test theories using process tracing, since process tracing requires a great deal of data. So, you need data rich. Data richness can take several forms. Abundant archive data can be available. Participants in the case may be alive and available for interviews. Other scholars may have studied the case for their own purposes and have done much legwork for you. So therefore, this is the data for where you get the stuff, right? So the archive, there's a lot of archive data. Participants may be alive and be able to interview. And there's other scholars have done work on this, and they've done a lot of the legwork already. And you can just go get their stuff and then use what you think is useful for you and use the data from them and then test and making claims, right? Two, select cases with extreme high-low varies on the independent variable, independent variable, DV, or condition variable, CV, right? Recommending this selection criteria is Eccleston, right? This is one of those things, right? Under this method, we select cases in which we study variables, the variables whose cause and effect we seek to establish, is present in unusually large or unusually small quantities. 51. This extreme value method of case selection is closely akin to method 7 controlled comparison. The difference is only that with method 7 cases are selected to ease explicit cross-case comparisons, whereas here cases are selected to ease implicit comparisons to normal conditions, right? So explicit cross-case comparisons here is implicit comparisons to normal conditions. Such comparisons are clearest if within case values on independent variable and dependent variable contrast clearly with their normal values. So therefore, they have to contrast. They must clearly contrast with their normal value. To test theory, select cases with extreme values on the independent variable. Such cases often strong test because the theory predictions about the case are certain and unique, as noted above in the chapter. It is often argued that one should select cases that are representative or typical of the universe of the cases, right? So they should take one that's typical and representative. The extreme value on IV method of case selection argues the opposite, right? In other words, the argument is that we should take typical ones, but if you're going to take extreme, you should take not the opposite situation. It is often argued that we should take the representative cases, but this case, extreme values, no, you don't want to do the typical. You want to take the not the representative typical. You want to take the outlier, right? Or the different extreme value in that sense, not the typical in that sense. The extreme value on IV method of case argues the opposite, that cases are atypical of their endowment with independent variance teach us the most, right? Thus I choose the 1914 case to test offensive theory, which posits that war is more likely. This is the 14. War is more likely when conquest is believed easy, partly because 1914 was the heyday of the cult of offense, a remarkable European elite that conquest was easy. Hence, before 1914, this belief reached its height, even seen before or since. Because it was extreme, it should have been. It should have extreme effects. If it had ever had any effects. Hence, these effects should have been widely visible in 1914, standing out starkly from European political landscape, and should have appearance and quality unlikely to be produced by measurement error or by the actions of the other courses. The prediction of offensive theory in 1914, therefore, are both certain and unique. The prediction effects are too large to ascribe to measurement error and to other causes, hence, the predictions are unique. The absence of these effects, likewise, could not be plausibly blamed on measurement error or the overriding effects of other phenomena. Hence, these could not mask or override such large effects. Hence, the predictions are certain. Hence, the theory possessed by the 1914 case is strong. Offensive defense theory would be strongly collaborated by passing it and badly damaged by flunking it, right? This is Causes of War. This is from his book, Causes of War, Volume 1, Chapter 7, right? Um, uh, in press. So, just go back up here. Some argue that selecting cases from extreme values on the IV sets up weak tests because passage of the test is very likely. High IV value should elevate some DV value even if the theory operates only weakly. Hence, the test is easy to pass. This view rests, however, on a false definition of strong test. A strong test is one whose outcome is a strong test is one whose outcome is unlikely to result from any factor other than the operation or failure of the theory. According to this definition, a test using a case selection for extreme values on the IV is a strong test. In other words, we should expect extreme results in such a test. Now, 53. I assume there's no threshold effect. I assume that is there no threshold effect, that the impact of the IV and the DV does not peter out about a certain threshold. With threshold effects, this selection criteria is less useful, right? That's why you can't use this. This criteria is not as useful with if there is threshold effects. If they occur, these extreme results are unlikely to stem from other factors. If they do not occur, this is unlikely to stem from any other cause other than the theory's failure. Hence, cases with extreme IV values are laboratories for strong tests. To make a theory, select cases with extreme values on the variable. If values of the study variable are very high, its causes or effects, if these are sought, should be present in unusual abundance. Hence, these cases or effects should stand out against the background of the case more clearly. This makes it easier to spot. Likewise, if the values on the study variable are unusually low, its causes or effects should be made more strikingly by their absence, right? In other words, again, to infer antitheta conditions, select cases with extreme and opposite values on the independent DV. So extreme values, but opposite, extreme and opposite, especially with very high values on the independent variable and very low values on the dependent variable. These cases where the theory posited causes an abundant present, but the predicted effect is notably absent. For example, to infer conditions required for literacy to cause democracy, we should select highly literate societies with authoritarian regimes. To infer conditions required for economic depression to cause war, we should select cases where deep depression occurred but no war resulted, and so on. Such a pattern indicates that the important antecedent condition is notably absent. The missing condition can be identified among conditions that are normally present but are absent in the studied case. 94. Under the selection method discussed for the previous four paragraphs, cases are chosen to highlight and contrast between observed and normal values on the IV and DV. Here, in contrast, cases are chosen to highlight the contrast between observed values on the IV and DV. Contrast between the IV. Sharply contrasts are sought in both cases, although the sort contrasts differ in their nature in that sense, right? To test a candidate antecedent condition, a condition that theory requires to operate or magnify its action, select cases with extreme values on the conditional variable. A high value on the conditional variable should multiply the effect on the IV independent variable and on the intervening variable, the int and the dv dependent variable. A low value on the conditional variable should leave the independent variable with little impact on the intervening variable and dependent variable. In both incidents, the predicted results are pronounced and hence less likely to arise from measurement error or actions of a third variable. 55. This selection strategy needs adjustment if the impact of the antecedent condition follows a sharp threshold. If the IV required some value on the CV to cause the DV, but further increases in the value on the EV have no effect, right? This is diminishing marginal return problem. This seed and fertilize cannot cause grass to grow without accompanying a rainfall. But beyond a certain point, enough rain is enough. Too much rain will drown the grass, right? So therefore, there's a threshold. Too much rain, more rain does not produce like this threshold effect. In this case, we should select cases with very low values on the CV and test the prediction that the IV would lack positive cause in such cases. Selecting cases with very large values on the CV is unfruitful, the conditional variable, since the very large values predict the same results as moderate values. In other words, large values predict the same results as much. So therefore, this is not a fruitful way. It's better to do it at the IV and the a DV level, right? That's why he says that. Okay, now turn to 3. Select cases with large within case variance in the value on the independent variable, dependent variable, or within the conditional variable across time and space, right? So therefore, you're going to select things with large within case, but over time and space. Obliquely recommending this case criteria is Eccleston, right? Um, to test a theory, select cases with large within case variance in the value on the independent variable. So there's going to be the independent variable. There's going to be large in case variance on the independent variable. These theories make predictions about the impact of the variance in the value on the IV. Hence, variance in the IV's value generates predictions. Hence, the more within variance of the IV's value, the more predictions we have to test. Such variance takes the form of a diachronic or synchronous change in the value of the IV. That is, changes over time, diachronic or synchronous change. Or is it because of the different periods of time, or is there a synchronous to this? Um, um, that is, change over time within the period covered by the case, or diversely, on the value of the independent variable across regions, groups, organizations, or individuals' presence in the case. So therefore, you have two things, either across time or across groups, right? The groups, regions, groups, organizations, individuals in the case. Selecting cases for within case IV variance is especially appropriate if you plan to use congruence procedure type 2 for testing, since type 2 congruence procedures rely on observing within case variance. To make a theory, select cases with large within case variance in the variable, the value on the study variable, right? Whatever it is, IV, CV, whatever. The cause and effect of the study variable should also vary widely in such a case, in step with the study variable. This makes it easier to spot against the case background. Candidate causes and effects will announce themselves as the case characteristics that will vary with the study values variable's value. Study variable's value. That is that factor is present when the value of the study variable is high, missing, or when it's low, right? So therefore, it's okay. These conditions, therefore, the variation of the study variable and the background case, things in the background should kind of reflect that. To infer a theory's antecedent condition, select cases with large within case variance on the value of the dv and constant high values on the iv. Such a case contains some observation where the relative value on the independent value in the dependent variable match the theory's predictions. High on the IV and DV, and some where it does not. High on the IV, low on the DV. Candidate antecedent conditions will announce themselves as factors that are more abundant when relative values match predictions, that is, when DV values are higher. To test a candidate's antecedent condition, select cases with large within case variance on the value of the conditional variable. If the conditional variable is important, the DV value should be higher. Okay, if it's important, therefore the DV value should be higher relative to the IV value. When the CV is abundant, then when the value when the CB is abundant, then when it is scarce. In other words, you should have a situation where what is that saying? That if the CB is important, the DV value should be higher relative to this when the CV value is abundant versus when it's scarce. When it's scarce, it should not be as high. This should not be as high as this. The DV value should not be as high to the I relative to the IV value if it's not the CB is not present. 4. Select cases about which competing theories make opposite predictions. Right. In other words, take a case where theories make an opposite. This theory says this that this should happen, but the opposing to your theory. Okay. The theory says this should happen. And look at that case, right? Which competing theories make opposite predictions. This selection method is appropriate when you are more interested in testing the relative power of two theories than testing a theory against the null hypothesis. That is, if you prefer to arrange a Laocoonian three-cornered fight over two-cornered fight, okay, 57 on 2 and 3 corner spots. Read note 43 in chapter 1. This is the difference. The idea of two corners. In other words, two corners fight is we just test a null hypothesis and the existing test. But if we take another thing, a competing test to it, okay, we see this, right? If you are testing the relative power of two theories, choose cases about which they make opposite predictions. For instance, a case with opposite within case variance and values on two IVs, values on one IV fall over time, and values on the other rise over time. The DV should convey with the stronger IV, right? That is, two different theories. This is like this. They make opposite predictions. So therefore, if this raises over time, if this theory is true, they should reflect this. The DP should reflect this, or this on this. Or this. If this is doing this, this DV should be doing that. This thing that this theory holds. But the theory holds that if this does this, this should do that. But if the theory is this does this, this does this, this does this. Okay. So therefore, different opposite, right? That's opposite. This does this, this does this, this does this, this does that, this does that. So so these are the opposites. So therefore, if this does this, but then this does that, then you have a problem, right? So therefore you have a situation where you see that things should happen, they should follow the pattern that you should expect that they should follow. If they rise in the certain pathways, like I said, I'm sorry, I'm kind of upset about this. Um, the DV should covary, not covey, covary. I'm missing the okay, covary with the stronger independent variable. In other words, in other words, the DV, the way the DV takes should the stronger independent variable will do this. Right? They should follow the pattern. Should be good. If you're testing the relative power of two antecedent conditions, if you're testing the relative power of two antecedent conditions, choose cases where the IV is present and the CV shows within case variance. The values in one CV falls over time and the values of the other rise over time. The DV should convey with the stronger CV. For the best results, select cases that allow tests of predictions that are unique and certain as well as opposite. So not only opposite results, but also unique and certain results, right? So they should not only do as opposite, but they should test results that also are unique and certain. Number 5, select cases that resemble current situations and policy concerns. So what are the current problems and policy concerns? A theory inferred or from or tested with a case that resembles a second case will more travel to the second case that is operated in the second case as well. Hence, policy prescriptions deduced from the first case can be more safely applied to the second. Okay, so therefore, this is the idea: is that policy look for policy situations, and therefore you found it. Hence, you should find cases that are similar in that sense, the same policy prescriptions, right? So you look at, in other words, a theory inferred from a tested from a case that from a second case that is often traveled to the second case, brought to it, right? That operates in the second case as well, right? Hence, policy prescriptions deduced from this first case can be applied if you have the same, in other words, they resemble the thing. Scholars interested in offering policy prescriptions should therefore study cases whose background characteristics parallel characteristics of current and future policy problems. A study of healthcare policy in Minnesota yields more reliable prescription for healthcare policy in Wisconsin than studies of healthcare policy of Burkina Faso. In other words, these conditions are different. In other words, this is more similar to that than this is to that. Theories that operate in Burkina Faso may require conditions absent in Wisconsin. Hence, prescriptions deduced from these theories will prove unsound in Wisconsin. This is less likely of theories that operate in Minnesota, since Minnesota and Wisconsin are similar in many ways. Okay. Now, 6, select cases with prototypical background characteristics. Okay. One might select cases with average or typical background conditions on the grounds that theories that pass the test of these cases are more likely to travel well, applying widely to other cases. Right. So therefore, these are typical values. These are backgrounds are so typical; everything's the same. Right. So therefore, they're going to be things that pass here should be widely to other cases. This selection method is sometimes appropriate, but is overused. Sometimes appropriate, but it's overused. If one's seeking theories with wide application, it is often more appropriate to follow selection method 5, select cases that resemble current situations of policy concern, since that method offered better guarantee that collaborated theories will apply to other important situations. All right. Method 6 selects theories that apply widely. Method 5 selects theories that are less widely overall, but more widely important to circumstances. The latter's go is more often important. So therefore, this is, in other words, that more. In other words, so therefore, this is if you want. In other words, it's selection 5 is better than next 6. So method 6 selects theories applying that widely. Method 5 selects less widely, but overall more widely important to important circumstances. So therefore, this is interesting, but 5 is a better model, okay, to do it, interestingly, because why the situation would be similar if they do it, right? So 6, select cases, 7, sorry, 7. I'm tired. I've been doing this a little too long. Select cases that are well matched for controlled course comparisons. Okay, so select cases that are well matched for controlled cross case comparisons. Ugh. Well matched for controlled cross case comparisons. One can select cases to follow their pairing for controlled comparison. That is method of difference. Cases have similar characteristics and different values on the study variable, or method of agreement. Cases have different characteristics and similar values on the study variable, right? Different characteristics but similar values. So therefore, the method of difference being the stronger of the two is usually preferred. So there's the method of difference stronger than the method of agreement. Controlled comparison criteria can be applied to select one or more cases. A single case can be selected with an eye to comparing it to existing case studies that often have already researched and been written. Specifically, we plan to perform a method of difference comparison. We select a new case whose characteristics resemble those of an already studied case, but which has a different value on the study variable, right? So the value is somewhat different. Multiple cases can be selected with an eye to comparing them. In other words, if we plan to perform a method of difference comparison, we select cases with similar characteristics and diverse diverse study variable values. In other words, the study variable is diverse. So if a similar character, the study variable has different outcome, right? Or with existing cases, we select with characteristics similar to those already studied cases, but with differing values on the study variable. Okay? To test a theory using a controlled comparison method, select cases with similar characteristics and different values on the study variable. That is, select for the method of difference. The theory passes the test. The theory passes the test if the study variable reveals that the value on the IV and D value correspond across the cases. If, for example, IV has a higher value in case 1 than case 2, the DV should have a higher value in case 1 than case 2. Remember, however, the method of difference is a fairly weak instrument for testing theories, and method of agreement is even weaker. Hence, other selection criteria should have higher priority for theory testers. To make theories, select cases with similar characteristics and different values on the. So therefore, he's saying that this is not a good theory. That this approach, even if you're using this, is still not the best approach to making a theory. You can do it, but it's a weak test. To make a theory, select cases with similar characteristics and different values on the study variable. For methods of difference comparison, or cases with different characteristics and similar values on the study variable for methods of agreement consideration. Candidate causes or effects will announce themselves as differences in the characteristics of the compared classes when the method of difference is used. They announce themselves as similarities in the characteristics of compared cases when method of agreement is used. So therefore, in other words, the candidates for these things will announce themselves is that they will, a method of difference, these will, announce themselves in this, in the characters of compared classes with method of difference, right? They announce themselves as similar. In other words, they differ, right? They announce the things will differ out in their difference, right? In methods of difference and methods of similarity, similar when methods of agreements are used, right? This is how we test to make a theory in that sense, right? The method of difference is preferred when characteristics of available classes are quite homogeneous. So if you have if the variable cases are quite homogeneous, that is, most cases are similar, pick method of difference. Method of agreement is preferred when characteristics of cases are most heterogeneous, that is, most things about the cases are different. So method of when cases are different, when the things about the cases are different, use method of agreement. When most of the cases, the things about the cases are the same, use method of difference, right? To infer antecedent conditions, select cases using variants of the method of difference or the method of agreement. So therefore, using variants of the method of difference and method of agreement. For method of difference, choose cases with 1, similar values on the IV, 2, similar case characteristics, and 3, different values on the dependent variable. Candidate and antecedent conditions will announce themselves as difference in the characteristics of the compared cases, right? So therefore, they will announce themselves as differences in this case. So the method of difference will, this situation, they will announce themselves as things that are differing from the case, right? For method of agreement, choose cases 1, similar with values of the IV, different case characteristics, and different values of the dependent variable. The candidate antecedent conditions will announce themselves as similarities in the characteristics of the case of the compared cases. When testing a case antecedent condition, select cases with 1, similar values on the IV, 2, different values on the dependent variable. If the condition passes the test, if values on the CV correspond with the values on the DV across cases. In other words, they need to correspond. They test if this and this, and they pass. If the condition passes, if tests on the values correspond to the CV, correspond with each other on of the values of the DV dependent variable across cases, right? The corresponds with this, yes, exactly. Select cases. 8. Select outlier cases. Here, investigators seek cases that are poorly explained by existing theories, on the assumption of unknown causes explaining their outcomes, and can be identified by examining the case. We select cases where the values of the dependent variable are high and its known causes are absent. Candidates new test candidate new causes will announce themselves as unusual characteristics of these cases and as characteristics that correspond with the dependent variable with the case. So therefore, it's going to be unique, and that's going to be corresponding with this. To make a theory, in other words, you're not going to test the theory. You don't test this kind of theory. Okay, it's not that we can test the theory in this regard. We select. This is how we select them, but we can't use this to test. To make a theory, select cases where the DV is known. DV known causes are scarce, yet the DV is abundantly present. This suggests that unknown causes are operating within the case, and that suggests the case may reveal them, right? To infer an antecedent condition, select cases where the DV's known causes are abundant, yet the DV is scarce or absent. This suggests that unknown antecedent conditions are absent in the case, and that study of the case may identify them, right? So their absence, and therefore studying of this case. So select cases where dependent variable causes are known, and the known causes are abundant, right? Yet the DV itself is scarce or absent. Okay, so the causes for this is that. So something has to be present, either absent, or something's present that is not present in normal cases. Okay, so it's the antecedent condition are absent in this case, and the study of the case may identify them. Right. Number 9, selecting case of intrinsic importance. Selecting case of intrinsic importance, human or historic importance. Right. World War I, World War II, and the Holocaust. These examples, right, are is appropriate for our object is to explain course of history. We select such cases with a nod to their data richness. There is little point in studying cases where the record is too thin to answer our question, but mainly in accord with the magnitude of their human consequences. So therefore, we're going to look at this in the sense we look at how important it is. Now, we prefer cases that have good data richness, But if something is very, very important, maybe we will settle for less data richness. Number 11, select for case replication. Select for test replication. Although although theory testing requires replication initial test to collaborate with results, when doing this, we choose cases for their appropriateness as laboratories or replicate previous tests. Right. This is 59. Making this point is Lin in his case studies. In other words, we look at things that can be replicated. This approach considers multiple cases as multiple experiments. So multiple cases, test replication, not cross case comparison, is the goal of latter studies in this series. In other words, this is test replication, not cross case comparison, is the goal of latter studies in this series. So therefore, just remember, we're a laboratory of replications of tests. We're looking for replications. This selects considers multiple case as multiple experiments. Uh, Test replication, not cross-case comparison, is the goal. Testing. A replication can be exact or inexact. A quasi-replication, right? A replication can be exact or inexact. An exact replication repeats a previous test exactly with the similar results. A quasi-replication, which is far more common, repeats a previous test with some alteration to the research design. 60. To find quasi-replication, see Edward Balin's How to Design, Analyze, and Write Doctoral Master's Thesis, right? Um, um, Cases are selected by means of the same selection criteria used to select the cases for the test being replicated. So therefore, the means you do this with the cases are selected by means of the same selection criteria used to test cases for the test being replicated. So in other words, by the means of the same selection criteria to use to select the cases that are being of this. So therefore, why are you, you know, in other words, your cases are selected by means of the same selection criteria used to select the cases for the test being replicated. Okay, I understand now. What he's saying here is the test. Every type of test, certain kinds of tests will work with certain kind of cases better. The relationship between the kind of test and the kind of case have to fit. So therefore, certain tests you would select, if you're doing certain types of tests, you're going to look for certain kind of cases. If you're going to be using certain kind of case, if using a particular cases, you need to find a test that can work on that case. Not that it proves the result, I'm saying, but that it's able to test the case. Okay. Remember that the type of test you use is always going to be relative to the type of case you do. In that sense, and therefore, selection of these kind of this kind of thing will base upon the kind of case the type of case you're going to use. The cases are selected by means of the same method you use to pick the kind of cases that you'd use this kind of test for, right? So it's tied to the type of test you're going to be using. Different tests make different cases, but if you're going to do replicable case, you're going to do replication is using the same kind of test over multiple different things. Okay, that's the way you do it. Again, this is the test replication. Take the test and same test, using it to reply. Right. Now, last 11th criteria. Okay, select for previous omitted types of tests. Ooh. So in other words, omitted, not done types of tests. If a theory has already faced one kind of test, it may now be appropriate to subject to another kind of test. For example, if a theory has already faced congruence procedure case studies tests, it may be now appropriate to subject to a process tracing case study test. We select such cases for their utility as as trace processing test beds. In other words, it has to be for. In other words, if the case is not appropriate for a process tracing thing, then so therefore now we have for example is that we've used congruence procedures on this test. Now we got maybe want to think about using it as this, but it has to fit the means of a process tracing test in that sense, right? Can the investigator test a theory with the same case from which it was inferred? As I noted in chapter 1, 61, right, when discussing blind tests, right? This practice is criticized on the grounds that such tests lack integrity. The criticism rests on the preference for blind testing. The assumption is that data not used to infer a theory are less well known to the investigator than used data. Hence, the investigator using unused data is less tempted to sample the data selectively, right? Okay. Prohibiting the reuse of test theory inspiring cases for tests is not feasible in practice, however, and would cause a loss of a good deal of evidence. Other barriers against test fudging, for example, infusing social science profession with high standards of honesty, is more practical. It says again, he's repeating his point. It's not, in other words, no. You can use them. You can do this. You can. The idea, you shouldn't do that. No, you can do it as long as you're being honest, ethical. You're not cheating. You're not using any biases. Being honest with your bias, being open and transparent of what you're doing. This is a fine in that sense. In other words, infuse social science profession with high standards of honesty. Now, this gives us our famous model. This is the 11th. This is when is it appropriate? This is the question of when it's appropriate. Testing theories, inferring theories, inferring antecedent conditions. So data richness, yes for inferring theories, yes for testing theory, yes for inferring theory. This is useful for doing this. Intrinsic importance, maybe yes, maybe no. Why? Yes. The intrinsic importance only seems to be intrinsic importance, right? Intrinsic importance is useful to understanding intrinsic importance. Isn't useful to these other things, right? But it's importance for intrinsic importance. The point here is even more interesting. Maybe that the importance of the thing, and that we're willing to sacrifice some data richness. Okay, that's what I said in my talk about that a little bit earlier. Extreme values on the second criteria. Extreme values on the independent variable, dependent variable, conjunctive variable. Testing theories, yes, but only on the IV. When inferring theories, yes, but on the study variable. Inferring antecedent condition, yes, high on IV, low on DV. When testing antecedent conditions, yes, but on the CV, but not intrinsic importance. Within case variance and values of the IV, DV, or CV. Okay. Well, testing theories, yes, on the IV. Inferring theories, yes, on the study variable. Inferring antecedent conditions, yes, on the dependent variable. And studying antecedent conditions, inferring on the antecedent conditions, yes, on the dependent variable. When testing antecedent conditions, yes, on the conditional variable. Again, not important for intrinsic importance. 4, competing theories make divergent predictions about the case. Yes, on testing theories, yes. Inferring theories, not really useful. Inferring antecedent conditions, not really useful. Testing antecedent conditions, oh yes, that's available. And studying intrinsic importance, not necessarily. No. Resemble the current policy problem cases. Current policy problems cases, right? Cases of current policy problems, right? Testing theories, yes. Inferring theories, yes. Testing antecedent conditions, yes. Testing antecedent conditions, yes. So this is no qualifications. Sometimes useful for testing, but not inferring. Resembles to this is across the board this. Now, prototypical case characteristics. Testing theory sometimes. Again, this is why this 5 was stronger than 6, right? And then no, no, and no. This is why it's weak. It's sometimes available for testing and inferring, but antecedent conditions not at all. This is why 5 is stronger method approach for selecting than 6. 7, match cross-case controlled comparisons, namely method of difference or agreement. Testing theories, seldom. You can do it, but it's seldom there. Remember that it's if you do it, a difference agreement is the weakest. Method of difference is stronger than agreement, but still weak. That's why seldom. It's useful for creating theories. It's useful for inferring theories. So it's okay for inferring theories or antecedent conditions, right? But not for testing. It is seldom useful for testing. Now, outcome unexplained by other theories, such as outlier cases. Well, testing theories and in testing antecedent condition, no. These are not used for these two things. They're only good for using for when you want to infer new theories or you want to infer antecedent conditions. So outcomes, outliers are only good if you're trying to find out, not test the theory, but rather you want to find a test an antecedent condition or find an antecedent condition, right? The things. Number 9, intrinsic importance. Of course, no. Intrinsic importance, not important for testing theories. Not this, and yes, for intrinsic importance. This is what it is. It's is intrinsic. Do you have to use intrinsic importance to do this? No. You need this to do this? No. You need to do this? No. This, but only for this, right? So you need intrinsic importance for studying intrinsic importance. So this is the question of these are being done to achieve each of these, okay? Not these being done to achieve this, but these are being this method criteria, selecting a case, if you're going to be doing this. So if you're going to be doing this criteria useful. This criteria not useful. I'm doing that because good cases for replicating data. Okay, now this is interesting. Testing. When you're testing, yes, and testing theories or antecedent condition, yes, but when inferring stuff, they're not that useful. This is not that useful. Allows for new types of tests. Again, for testing, this is useful, but for inferring things, no. So this selection criteria is useful for either testing a theory or testing antecedent condition, but not for selecting this. And this also explains why these kind of tests like this and data richness are usually not important for this, right? This question is why this may be important is relative. Data richness is the only thing that impacts the question of studying an important transport is if you have a lot of data. In other words, does it have a lot of data so that you can address the case? Okay, it's an important issue. It's an important aspect. You have a lot of data that supports it. And this is the section of how we did the case selection. Now, if you have any questions or comments about this, please put it below, and I will answer it once I see it. If you liked it, like it. Please like the video. I'll do it over here. Make me bigger, yeah. Like the video. Share it with a friend. Share it on your social media. Spread the word. I hope that you find this useful in a sense. If you didn't like it, you can always say no, but tell me why. If you've not subscribed, please subscribe. And encourage others that you know to subscribe to help grow the channel. What else? You can follow me on social links below, the social media links below. If you want to follow me on these links, like I said, I'm usually more active on Facebook than other links, but I do occasionally on Twitter, but not really active that much on Twitter. I use it more for notifications and notices of things and things. Then my also things on my academic social media links are below also. And particularly if you want to know about my research and find more about me as a scholar, you can do that through those means. Another way, if you want to help to do what I do, help me to do what I do, you want to do it financially, to subscribe to our Patreon. You can do this. Um, um, there is a kind of people saying, "Well, you're not. No one's there. You're not doing much. You're doing this stuff anyways. Why should I help you?" No, it's not I mean, it's just a little bit. I actually could use some grant money or something like this, but I can't get grant money. I tried getting grant money sometimes, but I won't get it. Um, useful saying, "Oh, you're doing it." Well, by doing this, by if people do help me, it'd be useful. I appreciate it. And I will say thank you. Okay. But that's it. You can do that. Another way you can do it is by buying my books. You can buy my books. Links the books are linked below. You can buy them on Amazon or other online bookstores like Barnes and Noble. They should be available. If the last book, if you want to buy the Lulu book, buy it by Lulu, because by buying it by Lulu, we buy it Amazon. You buy the Lulu book by Amazon. Amazon gets a profit. You buy by Lulu, I get what Amazon other bookstores get. Okay, so it's a better way to do that. But that's it. We have one more video on this series, and then I'm done with this series. And that's it. Well, take care and have a good day. Take care. Bye bye.